Hello everybody and welcome to another Mystery Box Function Challenge. In the purple box there is some mystery math and your challenge is to figure out what that is. You can use the link in the description to try this out, and when you think you've got an idea, come on back, see if we get the same thing. Alright, let's begin. I'm going to put in a 0. 0 gives us 4, okay. How about a 1? 9. How about a 2? Oh, we're already up at 19, so yeah, that looks like a curve, right? Because we went up 5 and then we went up 10. Let's go in the negative direction here. 1.5, how about a negative 2? 0.25. I was thinking parabola, but now I'm not anymore. Let's keep going in the negative. I'm going to jump ahead a little bit. Let's do negative 5. And negative 8. And that's getting really, really close to negative 1, but not quite getting there. So I think that this is an asymptote. It's approaching this line, y equals negative 1. And looking at the shape of this sort of shallow curve here on the left, approaching some asymptote and then shooting way up on the right, this looks like an exponential function to me. So that's the shape I'm seeing. What is that function, though? Well, with an exponential function, we have some number raised to the x power, and then maybe we have other things going on. In this case, I think we're subtracting 1 from it, because it's usually the asymptote would be the x-axis here, but it's moved down 1. So I think we're subtracting 1, and then there might be a multiplier as well. So something out here. So let's first find our base. This number I've put down here is a, and you can tell that by whether these numbers are doubling or tripling or quadrupling. If it's doubling, the base is 2. If it's quadrupling, the base is 4, etc. So let's look at this. And actually, because I think we're subtracting 1, I'm going to add 1 back to see what the numbers kind of were before you did the subtraction. So this would be a 5, this would be a 10, this would be a 20. Those are looking a little more recognizable as numbers in an exponential pattern now, right? 5 to 10, that's doubling. 10 to 20, that's doubling. So if we put in a 3 here, we would expect that 20 to double to 40, but then subtract 1. So it should give us 39 if we put in 3. So let's go ahead and try that, see if we're on the right track. So 3 does give us 39. Now, so that means we've got a 2 to the x. So 2 to the x and then a minus 1. What about a multiplier here? The place I would look for that is where we cross the y-axis, because what we're doing here is we're putting in a 0 for the power. So 2 to the 0 power is 1, and then we're multiplying it by something and subtracting 1. So I think we're multiplying by 5. 5 times 1, this whole thing would be 1, minus 1 would give us that 4. And that's what we get here, is that 5. So 5 times, let's do it this way, 2 to the x minus 1. So I think that's our function. We could try this out. Let's try it with a negative 1. So that would mean we have 5 times, well, 2 to the negative 1 is 1/2. So 5 times 1/2 minus 1. So that's 5 halves minus 2 halves would be 3 halves, or 1.5. That's what we get. So I think we've got this. I think it's 5 times 2 to the x minus 1. Let's go ahead and look. Yeah, there it is, 5 times 2 to the x minus 1, and let's graph that. And there's our beautiful exponential curve shooting up really quickly. We've just moved it down 1 with the subtraction, and we've multiplied it as well. Well, how did that go for you? Did you see exponential? Let me know. Thanks, everybody.